Hello guys, welcome back to CP Fundamentals, and today it's gonna be about digit queries problem. So let's take a look at the statement first. Consider an infinite string that consists of all positive integers in increasing order 1, 2, 3, 4, 5, 6, etc. And our task is to process Q queries of the form: what is the digit at position k in the string? So the input, the first line is gonna be an integer q, the number of queries we have to process, uh, and then after that we have q lines that describe the queries. Each line has an integer k, and uh, we have to print out a one indexed position in the string. Okay, for each query we have to print out the output, the corresponding output. So what do you guys think about this problem? What is your approach? Well, I must say that the common approach is gonna be uh, create a string first, and then using the position, the provided position, to locate the exact digit in the string. However, due to our constraints here, as you can see that q is lesser or equals to 1000 and k is less than or equals to 10 to the power of 18, which makes our time complexity is q times k, which is way larger than uh, uh, 10 to the power of 18. To be exact, it is 10 to the power of 21, and we cannot come up with such an approach like that, because when you create a string with such size, your code might get time limit exit or memory limit exit, and so on. That is not a wise approach. Rather, I recommend you with the following solution. So as you can see that we can divide it, our infinite string, into different blocks which represent the number of digits they have. So the first block have one digit from 1 to 9. The second block, the second digit block, is gonna be from 10 to 99. The three digit block is gonna be from 100 to 999, and therefore we came up with 9 numbers. 9 times 1 equal 9 numbers in the first block, and then 90 times 2, which make us 180 numbers, and the third digit block here is gonna be 2700. numbers. Do you see any sequence here? If our if C is the digit of the number, then wait, if C is the digit of the number, then we can determine the range of that number by the formula 9 times 10 to the power of C minus 1 . Oh. Wait, digits, I'm sorry. So you can notice that if C is the digit of the number, then we can first determine the amount of numbers that appearance in that range. For example, for one digit we have 9 times 10 to the power of C minus 1. C now equals to 1. 1 minus 1 is 0. 10 to the power of 0 is 1. And 9 times 1 equals 9. And that way we can determine the number. Then we can determine the number of digits from that block by multiply this formula by C, and then we have the digits. So my approach is that given a k number which represent the the string is kind of big, yeah. You can see what I was talking about way better here. So the statement k is the position, and then we can use this position to determine the block of our digit, and then we can determine that number and also their digit. So the code is better visualizing my solution. I want to keep all of number in the data type long, so I'm gonna use it throughout the code. First, we're gonna initialize the variable k, q and k for queries. And we have a soft k And we also need a bin pound function to calculate this formula. Maybe we can make this look more beautiful. So C is gonna be the current digit of the block. We're gonna initialize P equals to 9 K minus P C++ and P equals to 9 times bin pound of 10 and C minus 1 times C. So if K minus P 0 break, so I'm gonna initialize the letter P as 9, and throughout this loop we will examine the value of P. If K minus P is less than or equals to 0, we break this loop because we can determine the range, the block that our digit appears. Each step we will minus K by P and C plus 1, and yeah, using this formula I mentioned earlier to calculate the number of digits. After that, we're gonna convert K to the zero index system, because I'm gonna convert our number into string and then using the position to determine that digit. So with this, K divided by C, K diff C we gonna determine that number, and then we can determine the digit by modulo k by c. So the next part is gonna be create the number. And then yeah, from here we can create that number, and then create convert that number to string to determine that digit. All right. We have x, which is the number in the block, and y is gonna be the digit inside that number. We have determined the block here. We have the bin pound. Yeah, I think we should run the test cases to see if our code is correct or not. Yeah, all correct. And now I think I should submit this code to so that is the solution for digit queries problem on CSES. Thank you for watching, and if you find this video and other videos useful too, you can leave a like and also a subscription to my YouTube channel. Thank you.